بسم الله الرحمن الرحيم. أبنائي الأعزاء طلاب ثانوية عامة، إن شاء الله النهاردة بإذن الله هنتكلم على شابتر 2، وشابتر 2 بيتكلم على الكيميكال أناليسيز، والشابتر ده مهم جدا. وطبعا المفروض كان الشابتر ده يبقى شغل عملي في اللاب، لكن احنا للأسف هنقدر نستعرضه بشكل إن احنا هنتخيل إن احنا موجودين في اللاب وبنعمل ديفرنشيت ما بين الجروبس اللي موجودة عندنا، وهنستعرض مع بعض إن شاء الله. Chemical analysis is very important because we use it in different branches as medical field, as industrial field, and environmental field. It helps us to know the percentage of calcium, albumin, urea, uric acid in urine. It helps doctor to describe a treatment with have healing properties. We can use it in agriculture because chemical analysis help us to know the components of the soil and help us to choose the best type of plant which we can cultivate in this soil, and help us to select the suitable type of fertilizer which we can use in this soil. In environmental field, we can determine the percentage of pollutants as carbon monoxide, carbon dioxide, sulfur oxides, nitrogen oxides. It helps us to know the problem and help in solving this problem. How we can make chemical analysis? Chemical analysis have two main types, qualitative analysis and quantitative analysis. Qualitative, to know the components which is a substance formed, and quantitative analysis to show the percentage of each component. Chemical analysis, to make the qualitative analysis, most of substances are formed from two ions, positive cation and negative anion. Positive cation, we classify them into three groups. First group, dial HCl. The first question for us, why we use dial HCl as the main experiment, as the main indicator for the first group? Because dial HCl is more stable than acids formed from each one of them. This group include carbonate, bicarbonate, sulfide, and thiosulfate, and nitrite. All these groups, we will take them in form of salts, and we will depend on observation. Each one will produce a type of gas, and from the observation and record it, we can determine these groups. First, carbonate produce carbon dioxide because it forms carbonic acid. Carbonic acid is decomposed into water and carbon dioxide. Carbon dioxide, easily to detect it. We can detect it by using clear lime water, as we will see. Bicarbonate, another, produce carbon dioxide. Sulfide produce SO2, and we can determine the presence of it by K2Cr2O7, which changes the color. Sulfide produce H2S, bad smell, and change vapor weighted by lead acetate into black. Thiosulfate have more sulfur, so particles of sulfur suspend and formed yellow precipitate beside SO2. Nitrite group produce NO gas, which is colorless, and combine with oxygen forming NO2 reddish brown fumes at the mouth of the tube. This is the first group, dial HCl, and we will later explain it again how we can differentiate between different groups, carbonate, bicarbonate, sulfide, thiosulfate, and nitrite. The second group, the main agent is hot and cold H2SO4, sulfuric acid. Why we use sulfuric acid? The basic scientific idea which sulfuric acid is more stable than all acids will form as chloride, bromide, iodide, nitrite. Chloride will form HCl gas and we can detect it by using ammonia. Bromide formed HBr, which react with sulfuric acid and produce reddish brown fumes of bromine. Iodide produce HI, which react with sulfuric acid and forming iodine vapor with violet color. NO3 produce directly NO2 reddish brown fumes. The third group contain two groups, two radicals, two acidic radicals, sulfate and phosphate. The main agent to differentiate between them, we use BaCl2. BaCl2, barium chloride, with sulfate produce white precipitate insoluble in diol HCl. Phosphate produce white precipitate soluble in diol HCl. The three groups used to identify the acidic and the anion in substances. We must take care because the type of questions will change, not directly, not depend on remember only, but to understand again. We must know why happened, the change of color, why, the reason, which give the reason of changing of the color. The second is cation. Cation is more complicated than anion because we have large number of elements and some elements have more than valency as iron, iron 2, iron 3, mercury, mercury 1, mercury 2, as same. So copper have 1 and 2. So we said that cation analysis have more complicated due to presence of large number of elements and some elements have different valency, different states of valency. And we can classify cations into 5 groups. The first one, called group diol HCl, contain silver, mercury, and lead. Why we use diol HCl? We can ask it, why we use diol HCl? Because all of them are precipitate in form of chloride and form a precipitate as AgCl white precipitate. Second group is include copper positive 2. The main agent passing H2S in acidic medium HCl. It will give black precipitate from copper sulfide. Third group, and it is considered as an important group which have large number of questions in our exam. This group contain iron 2, iron 3, and aluminum. The main agent of this group is ammonium hydroxide because all of them are formed precipitate in form of hydroxide. Iron 2 hydroxide, white-green precipitate, iron 3 hydroxide, reddish-brown precipitate, aluminum, white gelatinous PBT, aluminum hydroxide, white gelatinous PBT. And this confirmatory test is sodium hydroxide. It will form the same precipitate. Iron 2 hydroxide, iron 3 hydroxide, aluminum hydroxide with the same colors. The fifth group contain calcium. Calcium, the main agent for calcium to detect the presence of calcium by using ammonium carbonate. It will produce white precipitate of calcium carbonate insoluble in water, so it appears as a precipitate. Now we'll go to study the first group, diol HCl. How we can differentiate between carbonate and bicarbonate. We must know that we are in lab and we do a practical work. To do the practical work, how we can differentiate between carbonate and bicarbonate. To differentiate between carbonate and bicarbonate, we will take a salt from each one of them as sodium carbonate, carbonate, bicarbonate. We will take a salt from each of them. Sodium carbonate, Na2CO3, with main agent dial HCl. This chapter, although it has large number of equations, but it has a main idea, because the main idea is double substitution. Sodium with chloride formed NaCl. We have two, we must balance 2 NaCl, and it will produce H2CO3. This is the idea which we use HCl, because HCl is more stable than carbonic acid. Carbonic acid will be composed into H2O and CO2 gas. It will cause effervescence in the tube. Salt, it will produce carbon dioxide, and the carbon dioxide will evolve it. To test the presence of carbon dioxide, we must pass carbon dioxide through clear lime water for a short time. What happened? During passing carbon dioxide through lime water, clear lime water, calcium carbonate, calcium hydroxide, CaOH2 plus carbon dioxide, it will form calcium carbonate, CaCO3. CaCO3 insoluble salt in water, so it appears as a turbidity. Change clear lime water into milky. This is the first experiment and the main experiment for the group. To differentiate between carbonate and bicarbonate, firstly we use dial HCl added to salt in solid form. It will produce effervescence and the carbon dioxide gas will evolve it due to presence of carbon dioxide. To test the presence of carbon dioxide, we will pass it over calcium hydroxide, clear lime water for short time. It will form calcium carbonate. Calcium carbonate insoluble, so it appears as a turbidity in clear lime water or milky solution. To know bicarbonate, we will make the same step. Firstly, get a salt contain carbonate, NaHCO3, sodium bicarbonate, plus dial HCl. Double substitution. It will form NaCl and H2CO3, carbonic acid. Carbonic acid less stable, it will be decomposed into H2O and CO2 gas evolve. And we can test the presence of carbon dioxide by using clear lime water. This is the main experiment. We will ask ourselves a question. By using the dial HCl, we can differentiate between carbonate and bicarbonate? We will say no. Why no? Because they give the same results. The first give carbon dioxide, the second give carbon dioxide. So we can't differentiate between them. And we will use a confirmatory test to differ between them. The confirmatory test is MgSO4, magnesium sulfate. It will produce with carbonate white precipitate on cold, but with bicarbonate it will produce white precipitate after heating. يبقى white after heating. So we can differ between carbonate and bicarbonate. We will take care in the new questions. It will be not depend on remember only. It depends on understanding what is we need from the chemical analysis. What is the confirmatory test? Why it form white precipitate on cold? Why it form white precipitate after heating? It will ask us what is the precipitate. It will form magnesium carbonate insoluble in water and appears as white precipitate. Bicarbonate will form a magnesium bicarbonate soluble in water, but if we heat, it will convert bicarbonate into carbonate and appears as a white precipitate after heating. This is the first two anions in the first group, carbonate and bicarbonate. We will explain the differentiate between sulfide and thiosulfate. The main experiment is dial HCl. We will get a salt from each one of these anions. Firstly, Na2SO3, sodium sulfide plus dial HCl. As we say, double substitution, it will form 2 NaCl, and we must put 2, and H2SO3. It decomposed into H2O and SO2. SO2 is a rating gas and colorless. We will test the presence of it by using paper weighted by K2CR2O7. K2CR2O7. Its color is orange. It will change into green. If it change into green, it means the gas evolved is SO2. They will ask us what is the reason for changing the color from orange to green. SO2 plus K2CR2O7 acidified, adding for it drops of sulfuric acid to make acidic medium, SO4. What happened? This equation is large, but it is easy to understand. SO2, K2, CR2, and sulfate, SO4, form double substitution and forming K2SO4, CR2SO4, bracket 3, and H2O. CR2SO4 3 have a green color, so the color change from orange into green. HCl with salt of sulfide, Na2S plus HCl. Double substitution, it will form 2 NaCl and 2 H2S. H2S gas have a bad smell. It has the smell of rotten egg, and we can test the presence of it by weighted paper by lead acetate, CH3COOH, bracket 2 BB, with H2S, CH3COOH 2 BB, with HCl, as with H2S. It will produce acetic acid, CH3, COOH, and BBS, black. So the paper change into black, becomes black due to evolvement of H2S gas. The third one, thiosulfate. Thiosulfate, S2O3, have more sulfur. Remember it, have more sulfur, S2, plus dial HCl as the main agent. It will form SO2, S, yellow precipitate, and water, H2O. It characterizes this reaction by yellow precipitate due to suspension of particles of sulfur, and it will form yellow precipitate. This is the main experiment between sulfide, and thiosulfate by using HCl. It will give an acid, unstable, it will be decomposed. The first one produce H2SO3 in case of sulfide, and SO2 gas will evolve it. And to detect the presence of SO2 by weighted paper with acidified K2Cr2O7, potassium dichromate, it will change from orange into green. Number 2, sulfide. It will produce H2S. It have bad smell and as rotten egg, and we can detect the presence of it by using paper weighted by lead acetate. It will produce change black color. Thiosulfate have more sulfur, so it will form yellow precipitate due to suspension of yellow particles in the solution. To make a confirmatory test for each one of them, first one, by using AgNO3, silver nitrate, it will produce white precipitate, change into black. Sulfide will form with silver nitrate, black precipitate directly. The third one, thiosulfate, removes the color of iodine solution. Iodine have bromine, have the brown color, so it will remove it due to formation of sodium tetracyanate. It will remove the color of iodine. This is the group of died HCl, carbonate, bicarbonate, sulfide, and thiosulfate. We have another one, nitrite. Nitrite if we get a salt contain nitrite as nitrite NO2, we get a salt contain nitrite as sodium nitrite NaNO2 plus dial HCl. Double substitution, it will form NaCl HNO2. HNO2, unstable acid. It will decompose HNO2, decomposed into HNO3, H2O, and NO. We will notice that there is an area colorless which contain NO. At the mouth of the tube, it will change into reddish brown fumes due to formation of NO2 because nitric oxide react with oxygen and form NO2. NO plus O2 produce NO2, reddish brown fumes. To detect the presence of nitrite, it will remove the violet color of KMnO4 acidified with drops of sulfuric acid. Why it remove the color? Due to formation of potassium sulfate and manganese sulfate. They are colorless substances, so they will remove the violet color of potassium permanganate. Dear student, we must study this part carefully, and we must we stay in lab and do an experiment. Every anion of this group have a certain gas produced, and we can detect it. Thank you. First group ended, and we will complete, and we will try to make this experiment in lab and give you a video. Thank you.